Mr. Bainey, and we're going to take a look at, hey, what's up, Math 1? We're going to take, hello, this is Mr. Bainey. Today's lesson is 21.3, HL Triangle Congruence. This is the final triangle congruence theorem out of the 5 that are in this unit. We've done the other 4 already, and they include ASA, SAS, SSS, and AAS, I think in that particular order. And this last one is kind of a different one, only because it doesn't use the, A for angle and S for side. It uses H and L, and H is gonna stand for hypotenuse. Hypotenuse, if I could spell here. Hypotenuse. L stands for leg. And these are parts of a special type of triangle, and that's a right triangle. So that means this triangle congruence theorem can only be used for right triangles. If you don't know a triangle is a right triangle, you shouldn't even think about using this one. And another thing you might notice about this is that there's only 2 letters here, whereas all the other ones use 3 letters. But pretty soon here I'll tell you why we only use the 2 letters in this particular one. Here on the second page is the, well, first of all, before I get to that theorem, you see here the types or the parts of a right triangle. So here we have a right triangle. The right angle needs to be somewhere in here, and you can see it's marked with this little square. That means it's 90 degrees. Whatever 2 sides connect to make the right angle are the legs. So we have 2 of those. And then the longest side, the side that's not touching the right angle, is the hypotenuse. The hypotenuse is always the longest side in a right triangle. So we have 1 hypotenuse, we got 2 legs. That makes up our right triangle. Again, this right below here is a reminder of all the other 4 congruence theorems for triangles. And finally, the triangle congruence theorem, HL. You can see that we end up with the same conclusion as the other 4 theorems. We end up with the triangles being congruent. And remember that is helpful to us because that means all 6 parts are going to be congruent from one triangle to the other. But if we have a right triangle, here's where the 3 parts comes in. We have a right angle, we have the pair of hypotenuse, and we have a pair of legs. And that makes up the 3 parts. Technically, if this were to be a theorem, it would be the SSA, triangle congruence theorem, but SSA only works for right triangles. I can show you why this does not work for other types of triangles, specifically for acute triangles and for obtuse triangles. This SSA would not work, and that's because I can come up with a different triangle where those 3 parts, the 2 pairs of sides and the pair of non-included angles, are congruent, but the 2 triangles clearly are not going to be congruent to each other. So if you'd like to see that, make sure you come and see me, and then I could walk you through that. But we don't have SSA in general. That's why we call it this, HL. HL is just a reminder that it's only for right triangles. Let's go to the example at the bottom here. We're going to determine whether there is enough information to prove that the 2 triangles are congruent. So triangle VWX is, I'm tracing it right here on the right, and YXW is a triangle that overlaps the first one. And whenever 2 triangles overlap, I recommend drawing them separately. It just makes it a little bit easier to tell the different parts, right, for each triangle. It's much easier to identify them. So here I have my first triangle is VWX, and then my second one is YXW. Mark the right angle there. That was given to us, right, at V and at Y. And we're also given that VW is congruent to YX. So I pretty much just copied the picture up here. I just separated the two triangles. Okay, now we got to figure out, do we have enough information here to conclude that the two triangles are congruent? We can come up with other parts that we know have to be congruent. And we do know that WX has to be congruent to WX. And that's because of the reflexive property. The reflexive property states that anything is congruent to itself, specifically for sides and for angles. And we have to state that because WX is from the left triangle from the first one, and then WX from the other triangle. They just happen to share that side. And now you want to make sure that we have a pair of hypotenuse and a pair of legs. So if here's my right angle, the two sides that join at the right angle are the legs, which means WX is the hypotenuse. And over here, WX is the hypotenuse, and that means VW and YX are legs in those triangles. So that means we have hypotenuse and leg, hypotenuse and leg. They are both right triangles. So that means the two triangles are congruent. We indeed have enough information. So the triangles are congruent by HL. Now remember that this would be side-side angle, or SSA, right? We have our two sides. This angle is congruent to this one because they're both right angles, but it's not included, right? The included angle would be W, and the included angle over here would be X in between these two sides. So this one's not included, which is why this would technically be called SSA. Here on page 1067, let's do the proof at the very bottom. We're going to use the HL congruence theorem to prove that the triangles are congruent. And we want to prove, we are given some information I'll go over, but we're going to prove that triangle ABC is congruent to triangle BAD. Here's BABC, and here's BAD. Again, just like on the previous example, these two triangles are overlapping. I'm going to write it up at the top. Just going to separate these triangles. So here is A, B, and C. And then the other one that's overlapping is B, A, D. Let's start our proof. We have our two columns. Okay, our given is that angle CAB and angle DBA, are right angles. And we also are given that AD is congruent to BC. They really don't give you a whole lot of space here, but we'll work with it. I'm going to have to go off the page. Before we try to come up with the second statement, and what often happens is after you put in the given, you just have no clue what to do. Highly recommend that you mark your picture. And they've done that sort of by putting the right angles there, but we also have some congruent sides. So I'm going to mark the picture that I have up above. I have angle CAB is that one on the left, and angle DBA is this one on the right. Those are both right angles. And we have AD is congruent to BC. So if you noticed, this BC and AD happen to be the hypotenuse for their triangles because it's the longest side. And remember that AB and AC make up that right angle. So those are the legs. Same goes for AB and BD. Those are the legs because they make that right angle. We do know that AB has to be congruent to AB. Pretty much the same exact thing that happened in the previous example. That's because of the reflexive property of congruence. And I have enough information now to get to my proof. So I have the hypotenuse here and here. I have a leg here and here. They're both right angles, which means they're right triangles. And that is plenty to prove that triangle ABC is congruent to triangle BAD. Okay, and we know that because of the HL congruence theorem. Okay, that's it for this lesson. Remember that you can use in this, the practice or the assignment that you work on, you can use the previous congruence theorems, including that ASA, SAS, and all that, in addition to what you learned here in this lesson, which is HL. Okay, so just keep that in mind, because sometimes you won't always come across right triangles, and if you don't, you can't use HL. You got to look to those other ones. All right, thank you so much for watching. Hope it was helpful. Have a great day.